Let's take a look at this example. This example is the projectile is find at point A. At point A with velocity at point A is equal to 150 meter per second. Okay. The horizontal distance, we would like to find the horizontal distance R. R is equal to what? Okay. At time in the air that is the time travel of this projectile. Okay, so then we have to starting with establish the fixed coordinate xy. That for this case we may set up xy coordinate at point A, that is the starting point. We set up like this. Okay, so then it means that at the final position, point B, the final position at point B reference to the point A, it should be 150 meter below the axis, the reference axis. So then it should be negative value. Okay, so according to this picture and the coordinate that we set up, okay, we may starting with consider the horizontal motion first. For the horizontal motion, we use the kinematic equation that for the horizontal motion, the particles is moving with the constant velocity, just only Vx component. Okay, Vx component. So then it's starting with at point A, that is the origin. Okay, that is the origin. So then xa is 0. Okay, and we substitute Vax, that is Va cosine theta. Okay, cosine theta is here. Okay, and from the problem is given us that the angle is defined by this rectangle, that is 3, 4, 5. This is theta, right? So then it means that cosine theta is equal to 4 over 5. And sine theta is 3 over 5. Okay. So for this case, we have the velocity in x direction is Va cosine theta. So then it's become this term, right? And after that, xb is r. Okay, so then when we substitute this value into this equation, we have r equal to 120 t from point A to point B. T is time travel from point A to point B. That's we would like to find. Okay, so now we have the first equation that with two unknown that we don't know R and T, A, B, right? Now we move to consider the vertical motion. Okay, for vertical motion, we know that for the vertical components, the particles moving with the acceleration, the constant acceleration that is equal to minus g. Okay, because it goes downward, we set up is upward as a positive. Okay, so then we can determine time from this equation because we already know yb and ya, right? For this case, yb is what? We set up the reference over here, and yb is below the reference. So then yb is become minus 150 meter. Okay, and ya, set up the reference over here, and at point A, ya is 0 because it is the origin. Okay, it is starting from this point. So then we substitute yb equal to minus 150 and ya is equal to 0 into this equation, and vay is what? Vay we know that VA is equal to 150 meter per second. Okay, this is theta, right? And VAY is the vertical component that is equal to VA sine theta. That is, we know that sine theta for this case is equal to 3/5. Okay, so then it means that VAY is equal to 150 times 3/5. Okay, times 3/5. That is the VAY is over here. Okay, so then we substitute this value into this equation. Okay, this value into this equation, we obtain that this is YB, right? And this become 150 times 3/5, that is become 90. Okay, okay, become 90, and this is 90 TAB. Okay, and it is plus a half. Okay, a half time gravity, that is minus 9.81 times TAB squared. So according to this quadratic equation, we can solve for TAB, right? We can solve for TAB, and we have TAB like this. Actually, when you solve this equation, you will get to answer, right? You get to answer that is from this equation we have time TAB equal to minus 1.54 second and 19.89 second. But because we consider the time interval, that is starting point at point A to point B, so then time is never be negative value. So then we select the solution of 19.89 second as the time TAB. That is the first answer. That is the time travel in the air, right? And then after that, we substitute time equal to 19.89 into the first equation that we have this, and then we can determine for R, the horizontal displacement R, that is equal to 2,387. Okay, that is complete of this problem. And then let's take a look this problem. Okay, this problem is we have a skier leave the ski jump ramp at point A, with the angle of 25 degrees, and he hit the slope at point B. Okay, so we would like to find the initial speed of VA. At this problem, from this problem, we already know the this distance between point B and this maybe we may define like point O. Okay, for OB is equal to 100 meter, right? Okay, and we set up the axis at point A, Okay, we may set up the axis at point A, and we know the slope of the part. We know the slope is defined by this triangle, that is 3, 4, 5. Okay, we would like to determine the speed, initial speed. Okay, so then if we set up the axis like this, so then for the projectile motion, we know that the horizontal component, the particles moving with the constant velocity, and the vertical component is moving with the constant acceleration minus g. So let's take a look for the motion in x direction first. Okay, we starting with x A, that is because we set up the coordinate over here, so then XA is become 0 and YA is become 0 because we set up the origin over here 0. And at the final position, XB is become what? This XB. XB is become 100 and this is maybe angle alpha. Okay, 100 and cosine alpha, right? And cosine alpha is become 4/5. Okay, so then XB is become 80, right? 80 meter. Okay, so we have XB is equal to 4/5 times 100, that is become 80. Okay, equal to 0, that is XA, plus VA cosine 25 degree, that is the X component, velocity in X component, time TAB. Okay, so now we have two unknown, that is VA and TAB. Okay, we can rearrange this equation to determine TAB in terms of VA first, that is equal to this. Okay, after that we move to the motion in Y direction, and we know that in Y direction we have the constant acceleration that is equal to minus G. Okay, so YB is become what? For this case, YB is 100 sine alpha, right? So that is equal to 100 sine alpha from triangle is equal to 3/5. That is become 60 meter. Okay, and oh, sorry, 60 meter is just the distance from the projection distance from point O to point B, projection in Y direction. And because we set up the origin over here, so then we have to adding the vertical distance 4 meter into 60 meter also in order to find the position YB. This is the position YB with reference with the x-axis. This is YB. Okay, so then YB is minus 64. Okay, substitute this value into this equation. We have VOY is V sine 25 and TAB. Substitute into this. I have G. Okay, this is negative value because it's G is the one. Okay, and then substitute time into this. And after that, we can solve for VA. Okay, we can solve this quadratic equation. So for VA, we have VA equal to 19.42 meter per second. That is complete for this problem.